So, okay, we did a few of these before break. I don't know if you remember, maybe, maybe not, but this is called same base exponentials. And the goal is to get the bases of the exponents to be the same. This one, it already is. When the bases of the exponents are the same, you can cancel them out. 2n minus 3 equals 4. Plus 3. N equals 7 over 2. I'm just going to leave it like a fraction. Okay, so that's that one. Now, number 11 is not as easy because 81 is not the same thing as 3. Okay, so what I'm going to do is go over here, take the bigger of my two bases, in this case it's 81, and I'm going to make a factor tree. 81 is 9 times 9, which is 3 times 3, 3 times 3. Okay, so 81 is 3 to the what? 3 to the 4th, because there's 4 3s. So I'm going to take 81 and change it to 3 to the 4th. Okay, now I have the same base, cancel them out. Negative x minus 1 equals 4. Plus 1. Okay, what do I do when I have negative x at the very end? Yes, Parker? Divide by negative 1 on both sides. Beautiful. Great job. X equals negative 5. They got lucky on that one. They don't usually come out as whole numbers. Okay. Any questions about the two warm-ups? 9 and 11. Everybody good? Okay. Next, can you guys look at the stamp sheet side for me? And tell me, what do I need to stamp? I don't think I stamped this, right? Or this, or this. Does this look correct? Do some of you have some of it stamped? I don't even know. Okay, so I'm going to do 72 to 75, and then I'm going to stamp whatever I can. Just so you know that tonight's homework is the quiz review, which is a worksheet in your packet. Okay. Yeah, I think I stamped some people, but not others. We'll see. It's going to be a fun mystery we'll solve together. It was 66 to 71, skip 70. Okay, you guys, so go ahead and set this set. Okay, you guys, so we're gonna do some review because I'm sure that you forgot everything, and that's okay. Uh, I don't know about you, but I was like writing the first period. It felt really weird. I hadn't written anything in like 9 days, other than my grocery list. Um, like, I don't know, my handwriting's off, but I'm sure I'll get it back together here. Okay, so first thing I want to remind you of is this is called a sequence. A sequence is a number pattern. We have two different types of sequences we were working with. Arithmetic, which is basically adding or subtracting the same amount each time. And then geometric, which is multiplying. Okay, what kind is this one? Arithmetic or geometric? Arithmetic, right? Okay. So the first thing we're going to say is this is arithmetic. And what makes it arithmetic is that it's adding the same number each time, which is 6, correct? Okay, and the letter for that is D. So the growth for an arithmetic is called D, and D stands for common difference, which means that there's 6 in between each number. Okay. The next thing I taught you was how to find the equation. And to find the equation, I told you guys that you needed to go backwards and find term 0. And I underline it because it's not really actually part of the sequence. The sequence starts at -8. But term 0 would be 6 down from this, which would be -14. You guys okay with that so far? Okay, so we call that term 0 is -14. Okay, and then I taught you how to find the equation. But today, I'm going to start calling that the explicit equation. Because there's actually two different types of equations for sequences. And this one, it looks like y equals mx plus b, if you remember, but it's t of n equals d n plus t0. Y equals mx plus b. And for this particular problem, t of n is 6n minus 14. And it should still feel like y equals mx plus b to you. Okay, I want to pause there. Anyone have any questions about what we did so far? Is it coming back to you a little bit? Okay, now for B, what we're going to do for B is we're going to figure out what term 46 is. So I'm going to put a little question mark under here and be like, what spot is number 46 in, or is 46 in? And so we write, okay, term what is 46? Term what is 46? And then I'm going to take my 46 and plug it into T of n like a backward function machine. So 46 equals 6n minus 14. Okay, so what is this saying? What does this mean? What did I do? I just did some really fancy business there. What is it? What is this saying? So we're gonna write it two ways. We're gonna write T of 10 is 46. So first 10th term is 46. 46 is in spot 10 is what I'm saying. The 10th term is 46. Okay, now for C. For C, I'm going to teach you something that new for this. It's the different type of equation, and it's called a recursive equation. Okay, I'm going to go slow on the recursive equation. It's very easy, but the symbols are weird. Okay, when I say recursive equation, I'm talking about how would like a little kid describe what's happening here? So like, let's say you have, I don't know, like a fifth, when do you learn integers? When do you learn like negative? Seventh grade, sixth grade? You're younger person, a younger person, if I ask them to describe this situation, I'm hoping that they would say the sequence starts at -8 and adds 6 each time. I think that's a pretty basic way to describe what's happening. Okay, so like somebody who's not in high school would not think to go, oh, if I go backwards one and then make an equation and then I could plug things in. Like they're not going to think like that. They're going to say things more basic. So they're going to say something like start at -8 and add 6 each time. Okay. Now, hopefully you've realized that that's not an equation. I just wrote it out in words, so the equation will make more sense. We're going to do it in two pieces. We're going to start with the start piece and then the add 6 each time. Okay, the start piece is easy. First term is -8. Okay, everybody good so far? Because the next part's confusing. Everybody understand where I got T1 equals -8, like the translating from start at -8 to T1 equals -8. Yes? Okay. All right. Now this is, I'm going to write it down and then we're going to go over what it says. Okay, write this down. And then we're going to talk about what this is saying because it's really weird looking. Okay, this part is saying the next spot. So T of n plus 1 means that you're going up a spot in your sequence. This is your current spot. Okay, so let me pause. Okay. First term is -8. To get your next term, which means you're going to go up a spot in the sequence, so you're jumping up a number. Take your current number and add 6. Get the next number, take that number and add 6. Get the next number, take that number and add 6. Okay, here's the good news. I know this looks really weird, but this part of the recursive equation, these three pieces, stay the same every single time. All you have to do is put the first term number here and the growth there. So really, it's easier if you just kind of memorize how it looks and then change up each number for each problem. I promise you, we're gonna practice it a lot of times, so it won't be as weird looking as it is now. Okay, and here we go, practicing it. I have a completely unrelated question. Did anyone see Zootopia 2 over the break? Not anyone, just me. I went, it was great. It was like almost even better than the original one. Now, I have to say, I'm a very large fan of that type of thing. I made Mr. Talbot go. He actually liked it. You guys are all smiling and shaking your head. It was really fun. There's a snake in it. He's super cute. Okay, so let's do number 73, and then I'll give you more time to set up this bottom part if you need it. Okay, let's go really slow. For this sequence here, what is D? Yes. Okay. And I know it's kind of annoying because the last one, D, was 6 also, but that's okay. Okay. So first question was, what was D? D is 6. Okay. Now the question that you wanted to answer, what is term 0? Yes. -6. Okay. Okay. My explicit equation is like y equals mx plus b. T of n equals d n plus t0. Okay, that's the one we learned before bridge. Okay, any questions? You guys all good? You sure? Okay, now we're gonna do the recursive. So this is only your second time of doing a recursive. And just to scooch this down a little, recursives have two parts. First, you say what the start is. So the start of my sequence is at 0. Okay, and then I say to get the next term, I take my current term and add 6 each time. So do you guys see how this and this and this are the same in every recursive? You just need to plug in the first term and the growth. Just say what it's doing. Okay, go ahead and write 74 if you haven't. Okay, 74. What is this saying in words? What is that jumble of symbols saying in words? What is this top part saying? Term 1 is 3. Okay, so that means start your sequence at 3. So you guys right here, write 3, comma. Start your sequence at 3. To get the next term, take your current term and subtract 1 each time. Okay, so I want to, just because we're learning right now. SSID, there's another two. Take whatever you need. Okay, so this is what this is saying in words. Start at 3, subtract 1 each time. Okay, so that means I'm starting at 3, subtracting 1, subtracting 1, subtracting 1, and then I'm just going to do dot, dot, dot. Okay, now I'm going to grab my other color. D is -1. What is term 0? 4. Okay, so what is my explicit equation? I've got my recursive. What's my explicit? T of n equals -1 n plus 4. Okay, now I have a little bit of spicy problems for you in 75. Spicy. Okay, our goal for number 75 is to figure out what this is saying. Figure out what equation I have, write the sequence, like just start it a little bit and then write the other one. Okay, so I'm gonna ask you questions. For A, is that explicit or recursive? Recursive. Okay, and what is the top line saying? Term 2 is 19. Okay, so what I want you guys to do is put 19 with 2 commas between it. It's saying term 2 is 19. So that means that's spot number 2. Okay, now what is this saying? Yep, so subtract 2 to get to the next one. Okay, so the next one will be 17, and then 15, and then dot, dot, dot. Okay, what will term 1 be? 21. And then, even more importantly, what will term 0 be? 23. That looks really weird, but well, there. Okay, so I have my recursive. I use that to write out the sequence a little bit. Now I'm going to do the explicit. T of n equals, okay, what's the growth? -2 and term 0 is 23. Okay, so now we're going to go backwards. We have the explicit. We're going to figure out what the sequence is, and then we're going to write the recursive. Can you guys tell that this is explicit right here? Because it looks like y equals mx plus b. Okay. All right, so this one, for some reason, we're going up by 6 each time in every single one of these. I don't know why, but what term is this? 0. Okay, and this is the most important thing about this one. You have to put the 8 in the blank. And they're going up by 6 each time. So that means your first term is actually 14. Okay, so now we're going to write the recursive last time. First term is 14. To get the next term, I take my current term plus 6 each time.